about fresh produce now. So one-third loss is even more than that when we have the not a proper facility. And in Middle East, of course, we have extreme weather conditions. So it's very difficult and important for us to protect whatever we produce. And even at the same time, we need to protect the product with care, though we are importing that. So, particularly, okay, that picture is nothing new for you. You can see everywhere. It may be now in Thailand, India, Pakistan, any other country. You can see the same picture. Fresh food. So, whatever the investment we do, whatever research we do, producing that good quality product, if it is not reaching to the consumer, so what we consider all the resources is wasted. And magnifies the number, probably those who are senior professor here will always say 1/3 never reach. When I was student, same number I tell you. Now you are student, you know the same number. So there is a huge losses, and when we say the magnitude wise, when we say the 1/3 is how much? We always think about money wise, monetary side, what's the losses? When we have considered the losses in monetary side and top 500 Fortune companies, their profit considering Apple, Microsoft, 500 companies, the profit of this company, or for yearly profit, is less than this one. So one estimated study is more than $1,000 billion US that loss. And even if we are able to protect 2% losses, it's sufficient to create African continent. So if you see that required. Now, for the fresh fruits, where we have the maximum losses, fresh fruits only. Highly perishable with a high moisture content, and the journey from starting, whenever we harvest it, the handling starting from harvest. Once we harvest the product and then reach to the consumer, the whole chain, when you see on the poster side, there is a chances get the damage of the product. So, what type of harvesting, how we are handling, what is our storage condition, at the same time, what different types of storage, how we handle it. Lastly, before reaching to the consumer, and there is a different aspects, different area that commonly happen. Sometimes during handling time, means harvesting time, product may fall down, that's initial damage. During transportation, we have number of multiple transportation. You can say the local product, how we transporting versus mode of transportation, even the imported and exported product, how the mode. Even the storage side, how we store it, making the storage. So all the factors contributing to the losses, to the damage of the product. And the challenge with that all damage is not visible instantly. It takes some time to visualize. So mostly cases what we consider, the product get a damage during harvesting time, maybe not exactly, sometimes some fruits will 24 to 72 hours it takes to visualize that. So particularly, when we talk about mechanical damage things and that damage happening three ways particularly, we come with a three different type of forces: impact, compression, or vibration. That is the main critically things happening with the product and where accelerating damage. So if you consider whole post-harvest value transportation chain or value chain from starting harvesting to the reaching consumer, there are many chances, at least it may be impact, maybe compression or vibration. They are accelerating the damage. So the occurrence happening particularly, just to give the example there, when the product is in the harvest get fall down and we keep in the boxes during transportation, it accelerates the damaging. So initially the small with the environmental condition it will accelerate. And challenge here, the bruising area, that's mechanical damage, we call it here the bruising for the product. It may be accelerated and increasing in time. Sometimes in the local market, transporting from one place to another place like India, north to south. If you talk about the Kashmir, going to the southern part of Tamil Nadu or Kerala, 3 days of transportation. The acceleration is going very high in the damaging side. Even the market side, you consider that's our practice actually. That's what we call here the impact. When the product falling down, it may be damaged. Like we have it, we go to supermarket, still India, we have that Mandi or somewhere. If you take the product, if you fall down, as a consumer, we are not going to do either again. What we do, we take that product, keep again, same boxes. Next consumer come, you don't know what happened to the product. But product is already damaged, which may be utilized after 24 hours or 72 hours. And then we come here the damaging with the time of the accelerating. And the price of the product, at the end, who is paying for that product? Because when the consumer looking the product, he wants some specific nutrients, vitamins or phenols. That's why the purpose of giving the food feature. If it's a damage, we are degrading quality of the product and even market importance. So that's the three forces always meeting happen: impact, competition, or vibration. Always say, which is responsible for getting the damage of the product. It may be impact that may be feel in the storage side when the product fall down. That may happen. In the compression, when we see the base that it will fill with the product, and that may be one thing. This picture we see here, we have the habit. We have the small boxes, but rolled in the order. The bottom side, the product always gets stress to get a damage. And coming to the vibration, that is transport side. It may be product to container. Sometimes we fill all the product and even the vehicles. That may be and some responsibles like the road condition where we transfer the product. And in the vibration, again, the human nature, particular driver behavior, that's also making something impact on that. But as a researcher, that's a problem. But our role is to get the solution actually. We know the damage, how to get the solution, and what will be the solution we are leading to. Initially, we need to assess actually how the damage is happening, what will be the criteria, how we can stop and getting the solution to protect it, actually, how the journey for the researcher side. And that may be the young researcher you are looking for that one. That's the problem, looking for the solution side. So particularly there is some method actually. We know the intensity of damage. When you see the mechanical damage, bruising is a small, bigger. How we know that one? So initially when we started that research actually in that area, just mimicking the real one. So mostly we can find a study on impact, pendulum side, compression, and vibration is similar to vibration. That may be studied commonly seen. Now, last 15 years, 20 years, when we see the people start to work on that area, up to what I say, up to 3-4 years back, very limited study in that area, very limited. So mainly focus on our manual measurements. It's a time-consuming process as well. If you check the any publication before 2020, mostly in the manual measurement, and they look for the impact energy, taking the bruise area, bruise volume, so the intensity. Of course, that was accelerated, and this is some experimentation, just like using manual way, and mimicking the experiment how the real work happening, like impact when they using the pendulum or drop test, and then making the damage. Like you can see that that's we calculate damage area, and in the depth side, then we calculate by the volume. And then are the area on the basic calculation with the impact energy, bruise area, bruise volume, and then we calculated with how the location we are getting, what the size we are getting, we calculate that. But that's up to this one. But now we will look that one. This mimicking process in the time-consuming one. Now we are pushing for the advanced methods actually. How this assessment we can do with some advanced techniques. So initially starting with mostly with the computer vision image starting to assess the damage using images. It may be our computer vision, thermal imaging, hyperspectral one, or excessive scan. So that approach they are leading to 4-5 years. There are big growth actually in the publication side, the research side, but in this area, what we see in the same time. So I just sharing some experiences with this one part of case studies we are doing. First one, coming with the case study what we did in the Sultan Qaboos University of the just impact, checking the damage with the impact test for the product and using the fracture dimension. Fracture intensity with the image put inside, see the tensional changes happening in the product. By using the EMTF, that's process. That is published already published in the book, the one. And for this one, you see the damage, and the surface plot where we have the more damage. So during this, there is the more damage on the product with a different conditioning one. And with this plot, we can say if the plot is smooth, there is a less damage, or no damage even the whole condition. But if the surface plot, we can say more damage, it shows the more damage. And here you can see with the display that the surface plot, we can get here last one where we have higher impact. Of course, it's the common actually when we have product dropping from higher height, it get more damage. And that's where, and in the last picture here we can see particularly this one, this area can lose like more damage, and in the surface plot also it's and then we try to correlate with the another quality parameter. So you will check the table for more detail. So look for the pixel dimension, looking for there are other properties, quality parameters, so we get to correlate with this. Then recent one coming with this one, okay, that's another study because when you're looking for that area, whatever the new research has come across, of course that's not from our side. But particularly assessment, particularly mechanical damages, and for thermal imaging is a good one because these are changes in the temperature when there is a damage in the product. Surely you should get more damage here, and this very well studied shown here when we have the highest intensity of that damage and temperature of that completely changing, and that may be a good indicator now that to look for the if the bruising is low or high using the thermal images as well. Then some models like finite element model, you can where look for the damage in one. So here let's be looking again at the product, and we started with the peer group, and we started that work recently with the Qatar University actually. So making the initial start, that's our initial try particularly in the finite element modeling. The peer as our model prop, and when we're drawing with the different surfaces, how it's behaving and how the intensity of damage, we're able to indicate that. So it will helping us actually, that's the problem. The assessment is important here, but it will lead us to go for the solution. So if you see the different picture, then we are drawing the different height as well as different surfaces, we're able to see the how the product is there. And then that information we are using to develop the new package. Now and again, we come here, okay, the assessment, the imaging, helping us to do the bruising with the help of, now here, every time we say about your option and you will look, there's another book actually, that of China, they come with very good solution because if you see the limiting the study of the dropping the product, after making the images, because that's also from another book actually, from the another book from China, but it looks more interesting actually, how they going for the assessment, and you can find this one, the advanced assessment techniques, whatever we see here, this is recent 2-year publication actually, we not able to find in previous times. And yet with the direct EI solution. Then another one with the hyperspectral, because the hyperspectral is the better than computer vision, but of course it's the expensive techniques compared to our computer vision, where in computer vision we just need a normal camera to RGB. But hyperspectral one, we have a little bit good advancement, we can detect earlier. Once get the tissue damage, we can hyperspectral, we know that ability, we can detect initially, so early damage, so hyperspectral commonly used. And now there's recent one with discrete element, like in finite element with a single element and we are dropping. In this case, like a combining one, they look for this one, check the damage in the product, but good part with this one, with hyperspectral or composition, we are unable to directly go for the tape. But discrete element is a good part here, we can go for not only the surface area, but volume, the in tape. And just to check their result, they also this group, they use exclusivity particularly to see how the damage we are looking for the discrete element is taken in the similar trade. So these are some advancement in the research work, particularly mechanical damage side, and this advancement is helping here to at least initial assessment of the product. So we can know before the product we transporting to another country in the local market, and with the advancement of techniques and look for the solution, because here the solution may become the one always solution come out the packaging actually. Always the researcher they are looking to get the best packaging. But in the threshold of the challenge, we want the research on the corrugated, particularly coming on the corrugated boxes. For local market, it may be making for the wooden or the plastic. But 70% for international market, whenever we transport the product, it may be corrugated. One of the challenges to best corrugated package with consider the factor from the packaging, because that may be deal with the solution side. Okay, solution side for this. So this all the assessment, quantification, and then go for the solution side. That may be the research where you, a researcher, may be contribute actually first with the best solution to come for this one. So for this side, we developed some method, we published that book, even mechanical level, particularly that area, and some solution side to the management techniques where we can assess that data. So indicatively, when we say the conclusion remark, always we say particular pros need to be protein, and every time, even HDG, Google, and other, and whenever it comes, say, okay, by 2030 we may reduce half postharvest losses. Okay, it's challenging actually. Means as a researcher, we work in the field, we not come, okay, we can reduce that losses, whatever we have, 50%, but there's supposed to be some way to achieve that. But practically in the 4 years, whatever the estimation, what they planning for, as well. So, when we see about mechanical, that's the important one. In the post-harvest side, we can always see whatever contribution we do, or research we do in the production side, because everyone want to do the good quality product. But production also equally is important here, and that may become the solution to the packaging side, your handling side, even protocols, particularly protocols for the particular different products. Because one solution not fitted for all. Like how we handle the banana and how we handle the strawberry, completely different. So with this I may stop here. So this is our research team actually. We work in the Middle East, particularly in the post-harvest technology and research team, and with our researcher, Dr. Nasser, is a PhD student in Bangkok, and which acknowledge our sponsors up to now to handle different courses. Okay, with this, thank you again.